coefficients of A and B. As we know that as we know that stimulated absorption or induced absorption induced absorption or stimulated absorption are dependent factors are the number of electrons present in the ground state, that is N1, and the transition of electrons from ground state to excited state we have indicated as B. From ground state to the excited state we have named it as B12, and amount of energy required to excite from ground state to the excited state we have indicated as rho V. So this induced absorption, the depending factors are the transition of electrons from ground state to excited state and the number of electrons present in the ground state and amount of energy required to excite ground state to the excited state. And in the spontaneous emission, in the spontaneous emission, we required factors are the number of electrons present in the excited state, that is the number of electrons present in the excited state, that is N2, and that spontaneous emission or occurs in the excited state. So from excited state to the ground state, this 2 to this one, we have named it as A21, from 2 to emission of photon. So these are the dependent factors of spontaneous emission. And stimulated emission, dependent factors are the transition of electrons from excited state to the ground state, that is B21, and the number of electrons present in the excited state and amount of energy required to emit more photons, that is rho nu or rho v, that is rho v. In the stimulated emission, the electron is already in the excited state and we are going to supply the energy to the excited state which emits two photons. Therefore, the dependent factors are amount of energy required and the number of electrons present in the excited state, and the electron transition occurs from excited state to the ground state, that is B2. In this, the system under thermal equilibrium, the system under thermal equilibrium, the system under thermal equilibrium, thermal equilibrium, that is the number of that is the number of upward transition is equals to the number of downward transition. There are two emissions occurs from downward transition, that is the rate of the rate of induced induced absorption induced absorption is equals to the rate of is equals to the rate of spontaneous spontaneous emission plus the rate of stimulated stimulated emission. And this may be written as the rate of induced absorption are the factors of the transition of A, sorry, the transition from this will be the B12, that is the rate of induced absorption B12 N1 rho V is equals to spontaneous emission, that is A21 N2 plus the rate of stimulated emission, that is B21 N2 rho V. Here rho V term taken common, B12 N1 rho V minus B21 N2 rho V is equals to A21 N2 A21 N2. Rho V is equals to this A21 N2 divided by B12 N1 minus B21 N2. Here divide numerator and denominator by B21 N2. Considering numerator and denominator by B21 N2. So this equation written as A21 N2 divided by B21 N2 the whole divided by B12 N1 minus B21 N2 minus B21 N2 divided by B21 N2. So after the simplification of this equation, it will become A21 divided by B21 the whole divided by B12 N1 divided by B21 N2 minus 1. So taken as this equation as 1. Equation 1. Here by using by using Boltzmann distribution law, by using Boltzmann Boltzmann distribution law, that is the number of availability of electrons in any energy level can be written as Ni is equals to N naught e raised to minus Ei divided by KBT or KT, where where N naught is the total number of availability of electrons. The total number of availability of electrons. Availability of electrons. Electrons. So where we are considering I is equals to 1, where I is equals to 1, this will becomes N1 is equals to N naught e raised to minus E1 divided by KT. KT. And so where I is equals to 2, this will become N2 is equals to N naught e raised to minus E2 divided by KT. So when N1 divided by N2, this will become N naught e raised to minus E1 divided by KT, and N naught e raised to minus E2 divided by KT. And this will become N1 by N2 is equals to, so this one get cancelled, N naught e raised to E2 minus E1 divided by KT, where E2 minus E1 is H nu divided by KT, where E2 minus E1 is equals is H nu is KT. This is the equation 2. Substitute in the equation 1. The equation 1 substitute, equation 2 substitute in the equation 1, it will become this will become that is rho of P is equals to A to 1 divided by B to 1 whole divided by B1 2 divided by B2 1 e raised to h nu divided by kt minus 1. So this is the equation number 3. This is the equation number 3. According to according to Planck's according to Planck's radiation law, according to Planck's radiation law, the statement of and the equation of Planck's radiation law is rho v is equals to 8 pi h nu cube divided by c cube into 1 divided by e raised to h nu divided by kt minus 1. This is the equation number 4. Equation number 4. Compare compare equation compare equation 3 and 4. Compare equation 3 and 4. Here a to 1 divided by b to 1 A21 divided by B21 is equals to 8 pi h nu cube divided by c cube. 8 pi h nu cube divided by c cube, and B12, that is B12, and comparing the equation 3 and 4, A21 divided by B21 is equals to 8 pi h nu cube divided by c cube. A21 divided by B21 is equals to the 8 pi h nu cube divided by c cube, and B12 divided by B21 which is equals to the 1, or we may write it as B12 is equals to B21. B12 is equals to B21. Or this equation may be written as, or A21 divided by B21 is equals to the 8 pi h divided by lambda cube. So this equation, this and this are Einstein coefficients, Einstein coefficients of A and B. Thank you.